Okay, before we introduce coterminal angles, we want to apply our learning. Radians have great application. We're going to throw this in there because it's kind of a nice, nice short piece we can think about. And that has to do with arc length and area of a sector. You've learned this before. You may not remember it. Within a circle, you have an angle for a sector. And this red length here refers to the arc length. We use the variable s to represent the length of that arc. Does anybody remember from geometry the formula for arc length? That would be a no. So let's see if we can figure it out. Because if we don't know the formula, it should make enough sense that we can just figure it out. So if we were supposed to, say, find the entire distance around the circle, what formula would you use for that? What formula gives us the entire distance around the circle? 2 pi r, which is circumference. So let's start with that. Everybody agree 2 pi r is the distance around the circle? Circumference? That one you kind of remember, right? Most days? All right. We don't want the entire distance around the circle, do we? We want a fraction. We want like half or a fourth or an eighth. What fraction do we want? We want the fraction theta over 360. That's how much of the circle that we want. So see how we took just basic knowledge of, geometry and we came up with a formula. Not too bad. So this is if you're working in degrees. Suppose I want to work within radians. Well, when we convert from degrees to radians, we take theta and we multiply by pi over 180, right? And we get a new theta that's expressed in radians. Well, look at my formula. Do you have a theta in the formula? Do you have a pi in the formula? Do you have a divided by 180 in the formula? Yeah, because you have 2 over 360, don't you? So look at how I write this. I could write the theta. I could write the pi. I could write the 2 over 360. And I could write the r. Isn't that what this is right there? Theta times pi divided by 180. Isn't that what I have? That simply converts it to radians, a new angle in terms of radians. So if we want to determine arc length, we just take the angle in radians and multiply by the radius. That gives you the arc length. It's that simple. So flip your page over so we can try one short example. It says find the length of an arc on a circle of radius 24 that subtends a central angle of 60 degrees. So I have a circle. I have an angle of 60 degrees. I have a radius of 24, and I would like to find the measurement of that arc right there. We will call it length S. That's what the problem is asking us to diagnose. All good? My formula is simple. S is equal to r theta, given that theta is in radians. So S is, what is the radius? 24. What is theta in radians? Pi over 3. So now I just have 24 times pi over 3, which is 8 pi. That was easy. Agreed? Agreed. Suppose we are going to do sector. Area of a sector. The area of a sector I'll represent by these green lines. That means all the space that fills up that. We use the variable k to represent area of a sector. My guess is if you didn't remember the formula for arc length, you don't remember the formula for area of a sector, but I bet you could come up with it. Instead of starting with circumference, we start with area of a circle, which is pi r squared. We do not want the entire area of the circle, so we theta over 360 gives us that fraction. Well, that's if you're working in degrees. So Suppose I don't want to work in degrees. I'm working in radians because radians are just better. The way we convert from degrees to radians, we take theta times pi over 180. Do you have a theta? Do you have a pi? Do we have a divide by 180? Not quite. What if I wrote it as pi times theta times 1 over 180 times 1 over 2 times r squared? Is that the same as what I have written up above it? Those are, aren't they? Now do I have a pi theta over 180? Yeah, so k is equal to 1/2 r squared, and this whole piece right there just gave us a new theta value. It's just in radians. So now we have a new formula for area of a sector. By the way, on the test, I give you these formulas. I give you the formula for arc length. I give you the formula for area of a sector. You have to remember to convert it to radians. Got it? So let's look at our last example, and then you'll be given time to work. Then you'll go to lunch. Find the area of a sector of a circle with radius 12 and central angle of pi over 3. You're right, that would be a 60-degree angle, radius 12. I'm going to mark as pi over 3 because I would like to use radians. Some people are like, oh, pi over 3, how do we even work with that? No problem. We have a formula. K is equal to 1/2 r squared theta. So K is 1/2 times, what's the radius? Squared, 144. Times theta, don't need to convert it. It's already in radians, pi over 3. What's 1/2 of 144? 72. And 72 divided by 3, 24 pi. So that is the exact value. If you didn't want the exact value and said, please round to the nearest tenth, then what you would do is you would take 24 on your calculator and multiply it by pi, and you would get 75.4. So it's approximately 75.4. If it asks for the value in terms of pi, please make sure that you write it in terms of pi. Okay. There we go. Here we go. Today, the second part of our lesson is to be able to determine coterminal angles. Coterminal angles, we need a definition. Coterminal means that the terminal sides are in the same position. So angles whose terminal sides are in the same position. So it's, you don't have to take notes, it's right off your worksheet, So take the worksheet that I grabbed you, you're going to take your notes at the top, we're going to do 3 or 4 problems together. Yep, we're actually going to do some of the problems with you. That's a lie. Everybody point at Henrik and say liar. Okay. So we'll give you an example. Okay. So here I have an angle. We'll call it 140 degrees. Just giving myself any angle. To show that it's 140 degrees, I use that arc as a rotation. Angles that are coterminal look like they're the same. They just maybe have different rotation. So as you can see, the terminal side of the angle is in the same position. But I'm going to show you an angle that's not 140 degrees, but has the same position as 140 degrees. And it would be that angle. Can somebody tell me how I figure out what that angle is? I would take 140 and I would add 360 to it, and I get 500 degrees. So 500 degrees and 140 degrees are coterminal angles. Angles whose terminal sides are in the same position. Could you find another one? You would just add on 360 over and over and over again. So do you agree that there's an infinite number of angles whose terminal sides are in the same position? Yes. All right. One negative. If I go the opposite direction, you can see I get 140 minus 360, which would be a negative 220 degrees. So 140 degrees, 500 degrees, and negative 220 degrees are all coterminal angles. Could I find another negative 1? Subtract 360 again and again and again and again. So, for the purpose of this, I'm asking you to simply just find 2 additional angles that are coterminal. One that's positive, one that's negative. Let's try 3 problems together. We start with problem number 1. You do not need to draw the original 100-degree angle. I think we all know what that looks like. It looks like this. I'd like to draw one that's positive, that's coterminal. So if this is 100 degrees, I need another one that's positive, then I'm going to go around again. And what would I get? 460 degrees. If I would like one that's negative, I will go in the opposite direction. Negative 260 degrees. So everybody okay with that? Please look at number 6. You have negative 78 degrees. This one's negative. Which quadrant would negative 78 place me in? 4th quadrant. You should have an angle that looks like this. Now, I'll do the positive one. I could just stop there for the positive one because it's negative. I just want one that's positive. Anybody know how I would figure that out? Negative 78 plus 360. When you add those together, 282 degrees. Which should make sense. You should be just past 270, which you are. And then I need another negative 1. Well, it already is negative. It's negative 78, so I need to go around again. So negative 78 minus 360 is going to give me negative 438 degrees. So again, these 3 angles, negative 78, 282, and negative 438, they are all coterminal angles. Does that make sense? Let's try one more. Flip it over and look at problem number 8. What's different about 8? It's in radians. If it's in radians, please give your answer in radians. If it's in degrees, give your answer in degrees. Okay? So 5 pi over 4, which quadrant is that in? 3rd quadrant, because it's 225 degrees. Everybody knows that because you've been practicing. So I'll do a positive 1 first. That's the 5 pi over 4. Then I'm going to go around again. I have 5 pi over 4, and what do I add to the 5 pi over 4? 2 pi. So my good friend Griffin said, Mr. Gens, we always reduce fractions. Why don't we make fractions bigger? Okay, let's do that, Griffin. It's 2 pi over 1. I can't add them together, so we'll make them bigger. I have 5 pi over 4 plus 8 pi over 4. Not really making it bigger, just renaming it. And there we have it. So you get 13 pi over 4. Finding the negative 1, you might be able to just look at it and know what that angle is. Negative 3 pi over 4 is correct. How do we do that? We take 5 pi over 4, and instead of adding 8 pi over 4, we subtract 8 pi over 4. And we get negative 3 pi over 4. That's that. And the rest of the time to practice that skill. So 2 simple skills today. You stay on pace. Tomorrow you will not have 2 skills like we've done the past couple days. We'll just have 1 idea, and you'll have a pretty decent amount of time to be working on that.